All right, good morning, everybody. I guess we will start off with what everybody's most interested in, and that is the exam. Exam 2 grades are now posted, if you haven't noticed. The average was about a 50. I forgot to print off. I made the little histogram thing, but I forgot to bring it. But it was a pretty normal distribution. A lot of people did good. A few people didn't do as good as they probably wanted or as I wanted, but that tends to happen sometimes. Jonathan is not going to have a block of time just because usually few people show up. But if you're interested in viewing the exam, just email him, and he will arrange a time for you to go view it, okay, with the answer sheet and see what you missed. So we're at the point in the class now where we've got a little over 50% of your grade covered with the 2 assignments and the 2 exams. So if you haven't been already, I suspect most of you have, but if you haven't been keeping up on your score, it's a really good time to assess where you're sitting right now, because you got almost half the points yet to change the direction or course or do better or whichever way you want to go. So it's a really good time to sit down and make sure things are on the right track. There weren't any questions. Everybody got 1 point added on, and that's showing up on Moodle already. Not because anyone missed a question that much, is because I screwed up on the answer key. I actually filled in the wrong bubble on the key, and so a lot of people got it wrong, so I just gave everybody a point due to my stupidity. But that's pretty much an exam 2. Any questions? Particular? Anything? No? Okay. Also, the second assignment that you guys turned in a couple weeks ago has been graded and posted. Okay, so there should be comments on there from Jonathan. And the third assignment, I posted the instructions and what to do like a week or 2 ago. So that's on Moodle. It's due, I don't know, a couple weeks, something like that. So those are the things that are coming up. Yeah, that's all I can think of. Okay, so before we get into, yes?
I have a question. So the in-class assignment, is that out of 3 points?
So the in-class assignments, those are the extra credit ones. I can't remember. I think the first one is worth 3 and the second one is worth 2. I can't remember exactly.
Alright. Like, how are they? So, because it said I got 2 out of 3 for one, and it's a D.
Oh, don't worry about if there assigns a grade with it. That's just Moodle. Okay. There's no grade. It's any points. They're extra credit. Okay. So there's 320 points possible. So those 2 points you got are going to go on top of that. Okay. So don't worry if the in-class little assignment things we've done, those are completely extra credit. I don't think Moodle actually will allow me to go in and selectively not show the grade for one of those. Okay. So I can see if I can do it, but those are completely extra credit. So yeah, don't. Even if you just got 1 out of 3 and you got an F, don't think of it as getting an F. Think of it as getting an extra point, okay? Yeah, any other questions? No? Yes?
You said that the second dietary assignment should be posted?
Yeah. It's not up yet?
It showed like your grade was affected by it, but it doesn't show where, like what your score is.
Okay, I will make sure. Jonathan was going to post it when I spoke with him last night. I will check after class, but they will be up. I thought, when I viewed, it looked like they were up, but I didn't look at it real close. But for sure, today they will be posted. So, okay. Any other questions moving forward? Okay. I guess before I get into some of this class stuff, Jonathan sent out an email. He's going to be actually the next few chapters. We're going to have some other people speaking, just so you guys don't get sick of me completely. So Jonathan's going to be doing a chapter, and then another PhD student in my lab is going to be doing the 2 mineral chapters, who is not a TA in this class. And then I will come back and do the last 3. So basically what we have left is, we've talked about kind of the food thing. We've talked about energy from food, the metabolism part, weight balance, all that. What we're going to cover now is we're going to cover vitamins and minerals. And then the last 3 chapters we cover kind of more lifestyle things, like specific nutrient needs when you're pregnant, when you're an infant, adult years, when you're elderly. Okay, so that's kind of the plan moving forward. So fat-soluble vitamins is what we're going to cover, but before we get into that, there's a couple of questions of the day. The gut bugs won't die, so we're going to keep talking about them. People seem to be very interested in this, which is okay. The question of the day says, have fecal transplants ever been used to treat obesity in humans? If so, has this been successful? So the answer is no, but there are at least 3 clinical trials going on right now. Okay? So this whole area, as I've kind of mentioned, the last 5-10 years, we've been trying to figure out, okay, what bugs are there and how do they change in different diseases? Now we're just moving into that next stage of, okay, can we manipulate them? Can we transplant them? Can we feed them differently to actually affect disease outcomes? And so that's where we're at. But we've done this in other animal models and it works, but in humans, it's just, and human studies take a long time, a very long time, because you have to get approval from like every person in the federal government. And taking someone's poop and giving it to someone else seems pretty straightforward, but it's actually very, very difficult because you have to go through this huge quality control. Because what if somebody has some sort of funky virus in there or something weird that could be transferred, right? Remember, this is how AIDS spread in the 80s, where people were getting blood transfusions because they didn't know about it. So there's a lot of quality control that has to go into this. That's why it's taken a long time. But you will be hearing about it probably the next 5 years, whether or not it works. And the second one, related somewhat to the same topic, is I said, you mentioned that the good bacteria in the gut feeds on fiber. True. In order to thrive. Is it possible that the same fiber also feeds the bad bacteria? And what are some ways we can avoid allowing bad bacteria to survive or thrive? And actually, it's just in the news today, talking about gut bacteria or gut bacteria competing, and how competing is a good thing. And the one thing we know is that if you look at people that have diseases, inflammatory gut diseases or obesity or anything, what you typically find in their gut bacteria is they have less diversity. So in other words, they have fewer species there. And we think that's a very bad thing. The more diverse your gut is, the better it is. And part of it is these guys keep each other in check. Okay? And that's what this whole thing talks about. There is some cooperation between bacteria, but most of it is competition. And you want this, because if you have good bacteria in there, they're, in theory, going to outcompete any bad pathogenic bacteria that comes along. And so to answer this question, a healthy diet will maintain a good, diverse population of bacteria. So when you eat that cheeseburger from wherever that has E. coli on it, and that E. coli comes in, if you have a good gut, diverse, healthy population down there, you are much less likely for that E. coli to take hold and cause you sickness than someone that has a very less diverse population. Okay? Now, regarding what food they eat, this is tricky. We have 1,000 maybe species of bacteria, and although fiber is a big source of food, it's not for all of them. And we think that some of the better ones, like the soluble fiber and things we talked about, but some of these more pathogenic ones grow off of things like sugars and various other things. But we still don't have 100% certainty. And to say bad bacteria, there's a lot of different types of bad bacteria, and they're all kind of different. But the take-home point I would make from this is that having a diverse gut bacteria, which will be fed by a good diet, will keep some of these bad guys from some staking claim simply due to competition. And that's the take-home point, yeah.
So what about probiotics that have one type of bacteria?
They're crap. The pun, get it? The pun. Okay, sorry. Yeah, so you know, there's, you see the Activa and the yogurt and all these types of things, and although those bacteria are okay, introducing one bacteria in the doses that they're using has such a little effect on this. And that's, again, the analogy I would use: if you walk into a tropical rainforest and you throw down one type of seed in that forest, is it going to overtake the forest? No. There might be a couple take hold, and that's it, but in the ecosystem, it's barely going to do anything. And that's the same way I think about the probiotic of delivering one bacteria. So, and there's actually, not to throw Dannon under the bus here, but they market the Activia or whatever, the yogurt that says the probiotics, gut health, all of this stuff. And there was lawsuits, I don't even know how they turned out, stating that these health claims are false because there's no evidence to show that. So, now that's not to say under some circumstances, some disease, you might be deficient in a bacteria or certain ones that adding it back could help. That may be, but for most people, it's not going to do anything. So, good question. Any other questions? Okay. Yes?
Is that the same for kombucha?
I don't know anything about that. So I've heard about this. It's a drink, right? It's like, is it a herbal drink?
Well, it's like they take tea and they add bacteria to it and then they ferment it and then they have flavor.
Yeah, I am not an expert in this. I couldn't tell you. All I know is I know one person that drinks it and they have horrible breath. So it might do something to the bacteria in your mouth for sure. But yeah, I don't know. I've heard, I could do some digging and see what I could find out, but I don't know. I'm sure no one's, like most things, I'm sure no one's actually tested it to see if it actually affects your gut bacteria, but maybe, I don't know. Okay. Okay, so we're going to talk about vitamins, and this is kind of the introductory slide, but we're going to mostly focus today on fat-soluble vitamins. Okay, so these are, of course, vitamins are required in our diet. They're absolutely essential nutrients, and we don't get them, we get disease, or we get sick, or in some cases we could die. All right, and the two classes that we're going to discuss this week and possibly Tuesday of next week are water-soluble vitamins, which Jonathan's going to discuss on Thursday, probably. And these are a whole bunch of different forms of B vitamins, and vitamin C is the lone non-B vitamin. And then what we're going to go over today are the fat-soluble vitamins, and there's 4 of them, A, D, E, and K. And so we're going to talk about where we get these, what they do in the body, what happens if you have too much or not enough, and some other random stuff about them. The one thing, they have different, obviously all of these have unique functions in the body, but the one thing that is really striking about the difference between these is the way they are actually absorbed. In other words, the availability of them to your body. And the water-soluble ones are almost always very available. So if you consume a water-soluble vitamin, so vitamin B or C, most of it is going to end up in your blood and can be used by your body. The fat-soluble vitamins is extremely variable. Okay? So my question is, why so much variability in this fat-soluble vitamins? Okay? And it's not so much the variability between the vitamins themselves, it's more in the context in which you eat them. Okay? Anybody have an idea why? Why under one situation when you eat vitamin A, it would be available to you, and one situation when you eat it, it would not? Yeah?
Eating them with fat.
Absolutely. So it's really important what you eat them with. So think about water-soluble vitamins. Your gut is pretty much filled with water, right? So these things can dissolve and they move around, they're happy. If you take a fat-soluble vitamin, let's say you take a supplement, take a vitamin D supplement, you drink it with a glass of water, it's not going to be soluble in that water. It's just going to form this little ball and nothing's going to happen to it. But if you eat it with fat in your diet, it's going to allow that fat-soluble vitamin to be dispersed and actually absorbed in your gut. Yes?
I actually take vitamin D supplements, and they say to take it with vitamin C. Why would that?
Oh, okay. So there are some
vitamin C rich
vitamin C and vitamin D together.
Yeah, like to help with like vitamin D absorb.
I don't know. I'm not sure why, but there are some of these that synergize with each other, and there's some that compete with each other too. I'm not sure about. Usually, you take vitamin D with calcium because those two are a mineral. I don't know about that one. I'm not sure. But to give you an example of this, there was a study. I think it was done at Iowa State here some years ago. Where they took people and they basically gave them a salad, okay, with a bunch of greens and stuff in it that had a lot of fat-soluble vitamins, and they just gave them that. And then they watched how many of those vitamins are actually absorbed, or they gave them their salad with a fat-based dressing, like threw some olive oil on it, right? And lo and behold, the differences were completely different. Those that just ate the greens got very little of the fat-soluble vitamins because there was no fat in the diet for them to dissolve. But you put the oil with it, and then most of the fat-soluble vitamins were actually absorbed. So this is something to think about when you especially if you're taking supplements. Vitamin D supplements are a common thing, especially, we'll talk about this, especially in winter in Minnesota, where we're not getting much. And taking it with something that has fat in your diet, with a meal, with something is quite important. Otherwise, it's just probably going right out the back door, feeding your bacteria, I guess. So, okay, so a little overview of kind of some of the different things going on here. Let's see. One of the things in the vitamins themselves generally are not digested, okay? So, if we're talking about like carbs or fats or proteins, we're breaking them down from something complex to get sugar, for example, or to get fatty acids or whatever it may be. Vitamins are pretty much there, okay? But we have to get them out of the matrix of the food. So in other words, they can be bound up in the fiber or whatever it is of the food. So we have to digest that part to get to them, okay? So that's an important process here, even though we're not digesting the vitamins themselves. For the fat-soluble vitamins, because, again, of the fat part, the bile is very important. So that bile acid produced in the liver, released through the gallbladder, going into the gut, is very important to help them, again, dissolve and make them available. Both of these are absorbed primarily in the small intestine. The primary difference between these is that, again, water-soluble vitamins, once they're absorbed, go directly into your blood. The fat-soluble vitamins, if you remember when we talked about fats, they go through the lymphatic system. So these go with the fat in your diet through the lymphatic system, which is an important distinction between these two. And the other highlight I'll talk about, and we'll get to this a little more when we talk about vitamin K, is, and I also alluded to this early in this semester when we talked about gut bacteria, so you can't get off this topic, is that the bacteria actually do produce vitamin K. And you can absorb some of that in your lower gut. And in some cases, it can be enough to prevent deficiency. Okay, so even if you're not eating much vitamin K, your bacteria can still produce enough in some cases to keep you moving. Okay. Okay. So the transport of these, as I mentioned, is based on solubility. Okay, the fat soluble, I mentioned it in that graphic there. Get packaged and go through the lymphatic system in these chylomicrons. So they get packaged with all the triglycerides and all the other lipids in your diet and go to the lymphatic system. And the water-soluble ones go into the portal vein. Okay. The other thing that's really striking between these is the storage in the body. So the water-soluble vitamins are typically not stored. So you eat them in excess of what you need, most of it gets excreted in your urine. Right? So if you're taking, if you look at some of these energy drinks, Red Bull, whatever it is, they have like 8,000% of your vitamin B6 or B12 or whatever. Most of that is going right out into the urinal, okay? Or, well, the toilet, I guess, if you're a girl, unless you pee in a urinal, which would be weird. So that's what's happening with the water-soluble. The fat-soluble, however, we can store, okay? So if you're eating vitamin D, A, D, E, or K, it can be stored predominantly in tissues which store fat, so adipose tissue and the liver, some as well. And this also affects deficiency or toxicity, because if you stop eating water-soluble vitamins, you have no storage to break down from, so you can become deficient really fast. Okay? A fat-soluble vitamin, if you stop eating it, you've got those reserves stored away, so you won't become deficient right away. Actually, it'll take quite a long time. Okay, so that's another distinction. And not only this also affects not only the deficiency, but also toxicity, and we'll talk about this in a little bit. You get too much of some of these and cause problems. Okay, so let's start off with vitamin A. So there are two, maybe I'll say flavors of vitamin A, different forms. One is called retinoids and one is called carotenoids. Okay, and retinoids are, so these can be kind of interconverted in the body, and I'll show you this. I can just skip ahead here a little bit. You can see retinol, retinoic acid, beta-carotene. All of these can kind of be switched around a little bit. But the retinoic acid or the retinoids are the active form, okay? So this we call preformed, so it means they're ready in the form you can use, And again, it's this retinol, retinol, and retinoic acid, okay? If it says ret, it's vitamin A, basically. And this is predominantly animal products. Okay, this is the primary source of this. The vegetable or non-animal sources are these guys, carotenoids, okay? These are what we call provitamins, so that means they need to be converted to the active form. They're like the precursor, okay? And the one that you see most common is beta-carotene, okay? And beta-carotene is, this is why carrots are orange, okay? Or if you eat too many, why your hands turn orange. And these can be not only in carrots, but also green vegetables, yellow-orange vegetables, blah, blah, blah. And here's just the graphic again. The plant sources you have to convert into these. So where we get these, again, when I go through, so I should mention here, as we're starting minerals and vitamins, I'm going to have some charts up like this, and many of them are going to have the RDA listed up here. Again, I will not ask you specific RDA numbers. I don't care that you know that. At some point in your life, if you stay in nutrition, you might need to know this in another class. But here, I'm not so concerned. I want you to understand basically what the vitamin does, what's important, if it's associated with the disease, too much or too little is associated with the disease, maybe some major foods that you find it in, okay, and something unique about the way it's metabolized or stored in the body, or availability. Those are kind of the big points that I want you to remember. And so the vitamin A, as I mentioned, the animal kind, the retinoids, you can see if you eat beef liver, which I'm sure you've all had for breakfast today, very high vitamin A. That's because vitamin A is stored in beef, just like us, in the liver. And so you're going to get a ton of that retinoids. But if you eat vegetables, kale, broccoli, carrots, sweet potatoes, all very high in vitamin A. And again, this is going to be mostly the beta-carotene, okay? That precursor form. And not all the vitamin A is actually equal. I won't get into this too much, but this form that has to be converted isn't quite as active. You actually have to eat more of this to convert into the active form, but it's not a huge point that I want to dwell on. Okay, so the absorption, I kind of alluded to this before. Like most fat-soluble vitamins, it goes through the chylomicrons in the lymphatic system, and the carotenoids are absorbed lower than retinoids, and this is partly why they're a little more active, the animal form. And most of the storage of this is in your liver. So I guess in some people, if you have some sort of liver disease, this can affect actually your vitamin A storage metabolism long term. Just something to think about. From the liver, it's packaged. If you guys remember, the way the liver kicks out fat is in these lipoproteins called VLDL, and vitamin A basically hitches a ride on these, and it's distributed to the rest of the body. So the brain, adipose, whatever tissue needs it, can take it up from the blood. And very little goes out the urine. So most of what we get, if it's absorbed, gets stored in the liver or used by other tissues. So what does vitamin A do? A lot. Okay? It does, a lot. This is a very non-exhaustive list of things. Let me start with probably the one that's most important, and that's the third one down here, is vision. Okay? We've probably all heard growing up, eat your carrots, it's good for your eyes, right? It's good for your vision. It's actually true, all right? The vitamin A in there is absolutely critical for vision, and as we're going to learn about in a minute, if you don't get enough vitamin A, the first feature you see in people is impairments of the eye or blindness, okay? So I will talk more about that. But absolutely critical for that. It's also really important for growth and development. If you are short of vitamin A, you will have impairments in growth and development. And it does a lot in signaling within your body. And so I had talked before in this class about nutrients not just supplying energy or supplying something, but also signaling or regulating things in your body. And vitamin A is a perfect example of that. So when you take vitamin A, not only does your body use it for various things like the vision and other things, but the vitamin A acts essentially like a hormone. And it signals, for example, goes into the cell, it binds a receptor, it goes to the nucleus, and it actually turns on that transcription, translation proteins that we all talked about. So it'll upregulate specific proteins that are involved in cell differentiation, cell growth, development, immune function, all sorts of things. So it's not just being used, but it also signals in the body. Okay, and this is true for most of the fat-soluble vitamins. Okay, so in addition to these, immune function, very important. Also, one where many of you have probably encountered it is in the realm of dermatology. Okay, so vitamin A is, if you look in many of your hand creams or lotions, they'll have something retinol, something on there. That's vitamin A. It's very good for your skin. And it's fat soluble, so you can actually absorb it through your skin. It's not just sitting on top. Okay, you can absorb it through. And so this is widely used to treat acne or other skin conditions. And last but not least, many of the plant-based ones, the carotenoids, are actually antioxidants, which are protective in the body. Yeah?
People who do juicing, sometimes they'll turn like completely orange. How much of an impact would it have on this?
So I have no idea. So the question is, if you do juicing, you can turn orange. I mean, if you get enough. I mean, the carotenoids, the beta carotene, definitely has this effect. There's no doubt about that. But you're talking about the signaling effect here. I don't know. Usually the juicing is a very short-term thing, and honestly, the juicing is. We haven't talked about this at all. From a nutrition standpoint, I don't know anyone that condones it. It's usually celebrities or some Kardashian or somebody that's promoting it. So, yeah, I don't know if I consider that a celebrity. Don't get me started. So I don't know, and so nobody's really studied this. It's more of a fad thing. I think that this whole juicing or the cleansing thing, okay, we haven't talked about the cleansing thing either, is really kind of insane, to be honest with you. And I hope I didn't offend anybody, because some people in there have probably done it. But, you know, not to get off target here, but the whole cleansing thing is, the argument is you want to detoxify your body, right? And my question is always, of what? Our body is built to detoxify things, okay? The liver is really, really good at that. And so by simply drinking some juice or things for 3-4 days, I don't see how that like flushes something out of your gut that would be toxic or cleans your body. There's no biological rationale for this that I am aware of. So it's usually just done to sell some product or make your name more visible or whatever it is. So, but anyway, but I don't. Going back to your question, I don't know the answer to this because no one's really looked. But long term, obviously, it wouldn't be good, right? The juicing thing, especially at certain windows of your life. Okay, so let's talk about deficiencies. And the deficiencies I mentioned with vitamin A, of course, I told you that the most important thing it does is vision. And it is one of the leading nutrient deficiencies in the world, okay? And in the U.S. you don't see it because pretty much everything is supplemented, or a lot of things are supplemented with vitamin A, and we don't have, generally our food supply is pretty diverse. Where if you go to third world countries, it's a big deal. And this is the leading cause of blindness, non-accidental. So someone pokes your eyes out, it doesn't count. But if you, leading cause of nutrient deficiency, blindness in the world, okay? And as I mentioned, it can be caused by liver diseases. So if you have something screwed up in your liver, for example, if you're an alcoholic and you have cirrhosis of the liver, it can affect this. But this is especially in poor countries and especially in children, okay? And it can cause night blindness, it can cause permanent blindness, and there's also, in addition to the blindness, I told you that vitamin A is really important for your skin, so there's some skin abnormalities that also come along with this. You don't need to know the full name here, but it basically causes some of your skin cells to die off and slough off, which is bad. Because we store vitamin A, we can also get toxicity, so the other end of the spectrum. So we can get too little, it can lead to blindness, but we can also get too much, okay? And we call this toxicity hypervitaminosis. It's a fun word to say. But you have to take a lot of this, okay? And this, a couple points I want to make about this. First of all, the dose you have to take is typically from retinoids, which are the active form. If you just eat the beta-carotene from kale and sweet potatoes and stuff, you can't reach toxicity, okay? Because you have to convert that to the active form, and when you get too much, the body will slow down that conversion, so that won't happen. So you can't OD on carrots, okay? But if you do get a lot of vitamin A, you can get toxic effects. And so you can get this from an acute. If you take one massive dose for whatever reason, you can see toxicity signs. Typically, the two more common ones are just chronic high vitamin A consumption over a long time. And the one that, I don't know if I'd say more common, but it's definitely more visible, is what we call teratogenic effects. And this is when you take it when you're pregnant, all right? And so one of the things that can happen, it's not so common, doctors are pretty aware of it here in the U.S., but when you're pregnant, or even before pregnancy, if you put on skin lotions, which have light of vitamin A, right? That vitamin A, like I said, can get absorbed into your skin. And one of the things that happens for some people during pregnancy is they get really dry skin or cirrhosis or whatever, so they put even more lotion on. Well, for us, it's probably not going to cause us to die or anything, but the baby is very sensitive. That fetus growing inside is very sensitive to this stuff. And so you can actually reach vitamin A levels, which will cause damage to that growing fetus. Okay? So this is something to be aware of, and this can definitely happen. And again, highlight the point that the plant sources, the carotenoids, the beta-carotene, is not toxic. Right, so you can't get that. And here's just someone's hands that are someone that has been eating too much beta-carotene in a normal person. All right. I actually had a friend of mine a few years ago that they had a son that had like an allergy to every known food on the planet, I swear. And basically his diet was pretty much carrots. And he looked like this times 10. It was really frightening. So. Okay, so just a visual. You can get to the point either through deficiency or too much where it actually can be fatal. Okay, doesn't happen very often, but it can be. But again, the deficiency here, the primary things you see are vision and skin conditions, and the toxicity stuff. You can again see I didn't go through all of these different things that it affects, but especially the teratogenic, the fetal complications. Yes? Yeah.
Still change your skin color, but it won't cause.
Right. It won't reach the level of toxicity. So yeah, you can't. It's hard to. I don't know if it's fair to correlate skin color with toxicity, because those can be kind of different things. So yeah, you can eat all the carrots you want, but you won't die from it, and it won't make your vision 20/20, even if it's crappy. So okay, so that's vitamin A. So now we're going to switch to the second fat-soluble vitamin we're going to discuss, and that is vitamin D. Okay, so vitamin D is what we call a conditional vitamin. Okay, so it is not always required in the diet. Why is it not always required in the diet? It's the sunshine vitamin. That's right. And vitamin D is a little bit like vitamin A in the sense that most of what we consume is that pre-version, or we call it a pro-hormone, because it acts like a hormone, because it's a precursor to the active one, okay? We'll talk about this in a little bit. So basically, when you get vitamin D, which you typically get in the diet, you have to convert it. It has to go through several steps in the body to actually get to the form that has effects. So it's not like you just eat it and it does its thing. Where do we get it? So vitamin D we get obviously from the diet, typically from oily foods. Okay, so fatty fish is a good source. Back in the old days, maybe your grandparents, their source of vitamin, you've probably seen this in the movies, or maybe even remember your parents taking cod liver oil or fish liver oil. It's really nasty stuff. very high in vitamin D. That's one of the big reasons they took it. Nowadays, you see it much more fortified, so it's fortified in milk, it's fortified in cereals, it's fortified in granola bars, all sorts of things, okay? And so you do see it around. Now the other form, as we mentioned, in addition to diet, is through skin. And so sunlight actually converts a form of cholesterol. So cholesterol is required to make vitamin D in your body, all right? Much like cholesterol is used to make hormones, estrogen, testosterone, it's also used to make vitamin D, which pretty much is a hormone. And so you get this type of cholesterol metabolite in your body, and then the sun converts it to this more active form of vitamin D. Okay? And then it gets further metabolized, and ultimately is the hormone or the full version of vitamin D that goes around the body and does its thing. Okay. I'm not going to focus so much on the needs for the moment because I'm going to come back to this. I just want to point out again here, fish, very high, oily fish, and you can see milk, mostly due to supplementation, and various other things have a little bit of it as well. But vitamin D is one that, without a conscious effort in the diet, and let's assume you don't get any sun, it's one that you can become deficient in fairly easy. It's not in a ton of foods like vitamin A. Okay? We'll talk about adult recommendations here in a little bit. For infants, it's also one, and we'll get to this, but vitamin D, they have a very high vitamin D requirement relative to other nutrients. Okay? Anybody know why that would be? Why would a baby or infant, little one, have high vitamin D? Yeah. Yeah, a big part of it is bone. So we'll get into what vitamin D does in a minute here, but a big part of it is bone development. And this is an age where bone development is, going really, really, really fast. Okay, so I want to focus on the sun part for a little bit, which sounds great. It'd be nice to see some sun. The sun, when it hits our skin, can, as I mentioned, convert this cholesterol metabolite into vitamin D. Okay, so what factors, if you want to get vitamin D from the sun, basically, what factors would affect how much vitamin D you can get? Okay, so if you were to go outside right now, what would influence how much vitamin D you can get from the sun? What factors would influence that? Yeah. Yeah, so surface area. Okay? So first of all, if you go out and you roll up one sleeve and you stick your arm out there, you're going to get a little vitamin D. But if you go out completely buck naked, you're going to get a lot more vitamin D, right? The neighbors might complain, but you're going to get a lot more vitamin D. So you can basically convert it anywhere in your body as far as I know. Okay? Yeah. That's a good one. Most of the sunlight is UV rays, so most of it penetrates a cloud. So not so much cloud cover. Maybe a little bit, but that seems like a logical one. Yeah. So how close the sun is, and what would dictate that? So time of year, absolutely. How about I just put season? Where's my eraser? So when do you think people in Minnesota would become deficient in vitamin D? Winter. It's absolutely true. So I have some colleagues that are in endocrinology, and so they look at all these people that get blood samples all the time. In winter, a lot of people, probably the majority of people they see in the clinic, are what they would classify as deficient in vitamin D in winter. Okay? And in summer, it comes back up. Okay? Everybody goes out to the lake, does whatever, but definitely season is a big thing. And this is, of all the vitamins and minerals we're going to talk about, this is the one where you definitely see the seasonal fluctuations. Yeah. What else? Exposure, season. Anything else? Yeah. Skin color, absolutely. So we know typically the darker skin you have, the more vitamin D you're actually able to make. Okay? So the whiter you are, the less vitamin D you're able to synthesize. What else? Yes? What's that? The length of time, absolutely. So surface area get length of time. So I'll put exposure time. Absolutely. It doesn't happen instantaneous. It takes time. What else? There's a few more you guys are missing. Yeah. Time of day, yeah. Not going to do much to go out at midnight, right? The sun's got to be up, and the sun's intensity, right? At noon versus 6 p.m. Is going to be very different exposure. What else? Anything else? Anybody ever been like a mountain climb or anything like that? You ever get sunburned on the top of a mountain? It's very easy to do. You're closer, you get more intense. So the actually altitude is a big one as well. So if you have, if you're living at sea level versus 10,000 feet, 10,000 feet, you're going to absorb more or get more vitamin D simply because of the altitude. What's one more that we're missing? Really big one. Okay? Really big one. Yeah. So latitude, yeah, absolutely. That's the other one. But there's one more big one. Absolutely, latitude is a huge one. And you can look and from the equator and go out, and it, for the most part, you can track vitamin D levels, or at least to some degree predict vitamin D levels based on latitude and season. What's the other one? Yeah. Yeah, sunscreen. What do we all do in summer? We go outside, you go to the beach or the lake or whatever, and everybody lathers up with sunscreen, right? Well, why do we do that? So we don't want to get burnt, right? Because if we get burnt, we get skin damage and we get cancer. And so this is an interesting paradigm because you have two camps of people. You have a camp of people saying, okay, you need sunscreen because we know too much sun exposure will cause skin cancer, and that's bad. Then we have a whole other camp of people saying, that's BS because we need vitamin D because we have all these vitamin D deficient people. And if you put sunscreen on, it blocks vitamin D synthesis. And so what's the right answer? I have no idea. But this is sorry, glad I clarified that for all of you guys. But this is a big deal because a lot of people that really layer up, especially in places like, Australia and New Zealand where there's the ozone thing and people like religiously put on sunscreens, that can have a big effect on vitamin D synthesis. So it's kind of a balance here of how much sun you want. But if you have a good diet, hopefully this won't factor in. Okay, so the absorption and metabolism, I'm not going to spend too much time on this because it's pretty much like the other fat-soluble vitamins, absorbed in the chylomicrons, so it goes through the lymphatic system. In the blood, there's certain proteins that carry it. You can store it in adipose, and more adipose than liver, but you can store it in both. And its metabolism is regulated by a hormone called parathyroid hormone, and we'll get into that here in a little bit. This goes through the whole process of conversion. I'm going to walk through it real quick. It's not a huge focus. Basically, when you take vitamin D from food, it gets converted, or get it from the sun, or the skin. It gets converted, let's see, down here. It's converted in the liver to this metabolite, and then it goes to the kidney. So both the liver and the kidney have a step in converting most of the vitamin D you get from the diet or from the skin into the active form. Okay, so if those two organs are screwed up for whatever reason, that can affect vitamin D status as well. Okay, so what does it do? So the big one, people think vitamin D, the first thing they think of is bone. Okay, so bone is primarily calcium and phosphorus, and so it's critical for making strong bones. Absolutely critical. So calcium and phosphorus homeostasis. Also very important in absorbing calcium. You had mentioned before if you take vitamin C with vitamin D. Usually a lot of your supplements that take vitamin D, there's calcium with it. Okay? Because the vitamin D will help the calcium get absorbed. Calcium is really a crappy mineral to actually become available to their bodies. It's very low availability, and vitamin D helps in that process. Okay, and it's also important. So we get calcium from. We'll talk more about this when we get into calcium. We get calcium from the diet, but if we're not eating enough, our body has a storage of calcium, and that's our bone. Okay, it's the most abundantly stored mineral in our bodies. And when we're short of it, we take it out from the bone. It's like our calcium savings account, so to speak. And vitamin D is very important for that. So it brings it in from the diet, and it can also get it out of the bone if you need it for whatever function in the body. So tying with that is obviously the bone health. These two are kind of the same to some degree. Immune function is very important. I won't go into the nuts and bolts of what it does, but deficiency of vitamin D can make you more susceptible to infections or all sorts of things. Cancer, with a question mark. So in the last, we went through this about 20 years ago. Vitamin E and A was all that was everything that everybody was focusing on. And then they kind of fell out of fashion. In the last 5 years or so, it's all been vitamin D. Okay, everybody's interested in vitamin D. It's going to be the nutrient that cures everything. And so there's a lot of interest, especially because so many people become deficient in it in winter, various latitudes, etc. There's been a lot of links to vitamin D and cancer. Now, whether or not taking vitamin D supplements to either recover a deficiency or go above that is beneficial, we still don't know. There's no conclusive answer to this. But this is a very, very hot area of research right now. And also tying in with that is the whole metabolic disease thing. So the whole diabetes, obesity, heart disease, all of this type of stuff. There's a lot of links, but there's no real hard evidence that vitamin D is involved in the development of these diseases yet. There's a lot of interest in it. So vitamin D potentially treating or preventing these diseases. Okay, so to give you a little bit of idea of what it does in the body, and this is kind of tying into different concepts of calcium and a variety of other things, okay? So if we have low calcium in the blood, all right, as I mentioned, so calcium, and I don't want to get ahead of ourselves, but it does a tremendous amount in our body, and so we have to keep the blood levels fairly constant. Okay? The low blood calcium, we're going to want to get calcium from any source we can, and that sources are A, bone, and B, from our gut. All right? And so what happens here is when you get low blood calcium, it releases this hormone called parathyroid hormone. Okay? It's from your thyroid gland. And this works with vitamin D to essentially get the calcium out of your gut, okay? So it's going to decrease the excretion of calcium because you're going to be absorbing more, all right? And also, the parathyroid hormone is going to help vitamin D to some degree too with getting the calcium out of your bone as well, right? And so the net result is you're absorbing more from the bone, you're absorbing more from your diet, and you're going to increase your blood calcium levels. I won't get so much into the high blood calcium level here. I don't think this is really critical. It can happen, but it's not. For most people, too much calcium is not an issue. Okay, so diseases. The big one is rickets. Okay? So did you see this in children? As you would imagine, so this little guy over here has rickets, and what you can see is bone deformation. So you can see his legs are bone, they're weak, they're soft. It's because of vitamin D, you don't have enough to help develop those strong bones. Fractures are very likely. All sorts of things. And this is almost impossible to recover. So early on it's important. And again, you don't see this so much in the U.S. anymore, but you do see it in other parts of the world. In adults, if a deficiency sets in, we don't get rickets because our bones are done developing, but we do see osteomalacia, which is basically a softening of the bones. Okay? And if the bones are soft, again, you're more likely to break them, all sorts of structural issues. So they're primarily deficiencies. Toxicities you cannot get from sunlight, okay? It is, or basically from the diet. Because remember, the vitamin D you get from sunlight or from your diet has to be converted. There's a couple of steps there to convert it into the active form. And if you get too much, your body will shut down those steps. Just like the plant-based vitamin A. Okay, your body has a way of doing it. Where you can get it is the over-the-counter supplements that sell the active form of vitamin D. And a lot of people, given on all this excitement about vitamin D and cancer and all this stuff, they're thinking, oh, I need to be taking a crap ton of this stuff, and it can actually reach toxic levels. So the upper limit, I'm going to talk about this, I'm going to come back to this, but this is recommended. I know a lot of people that take way more than this. It's probably much more than this, the level. And it can be fatal. Okay. So this in the last few years, as I mentioned, has become really hot topic, and people continue to debate how much vitamin D you need. And what the current recommendations are, which have been changed, I think the new book has it, the old one doesn't, is that the upper limit would go from 4,000, which I just told you, to 10,000 units. And the adequate intake, so the average what we should be eating should be 3,000 to 4,000, which is a pretty big increase from what people were recommending. But again, there isn't a lot of evidence to show that this is going to lower rates of cancer or prevent disease. We just don't know at this point. But people are trying to err on their eyesight.
So vitamin D, since you said soil, and it can be stored, can you like store it out in the summer and then like maintain throughout the winter?
So how long? So the question is, since it's fat soluble and storable, don't drop your computer. Can you build it up in the summer and then prevent it wear? I don't think it'll last that long. It depends, but I think for this, I hate to say with certainty, but I would say if you stop eating vitamin D altogether, that it would probably last you maybe a month or two. And to get through Minnesota winter, I wish it was only a month or two. Probably, even though you're having still some in your diet, it probably wouldn't. You couldn't rely on that solely. I don't think it'll help buffer it. I think going into the winter as having a higher level would be beneficial, but I don't think that would maintain all the way through. Yeah. Both. Yeah, so osteoporosis is really an interplay between vitamin D and calcium. It's kind of the thing where you can eat all the calcium you want, but if you don't have vitamin D, it's not going to be as good. You can take all the vitamin D you want, but if you don't have the calcium, it's not going to be good. If I had to actually give an example of two nutrients that synergize, this would be the first example I popped into my head, is calcium and vitamin D. They really work as a team. Okay. So we're plowing along halfway through that side of vitamins. The next one we're going to talk about is vitamin E. Okay. And vitamin E is again in two different sources. You can see the kind of a common theme here for fat-soluble vitamins. We have the tocopherols and tocotrienols. Okay, big chemical terms. Not a huge deal that you remember these. The tocopherols are the ones you're going to see most. These are the most active form. And where do you get them? Typically, plant oils are the big one. So anything with oils or wheat germ, various. It's kind of a variety of things. Okay, and this just shows the structures which are important. This just gives you some idea here. Again, different cooking oils will be enriched. Certain foods, nuts, generally dairy, vitamin E, good source. Peanut butter, various things like that. The RDA, so the recommended daily dose of this is about 15 mg, but there's a lot of debate about this, what actually you need that much to prevent your red blood cells from exploding, basically, okay, which is a bad thing. Now, that doesn't mean that 15 is enough for adequate health, okay? This isn't too big a concern. Most people get enough vitamin E because it's in such a diverse things of foods, as far as reaching a deficiency level. I should say most adults don't reach that level, but they don't get to the level where they see the deficiency effects. Okay, I'm not going to go over absorption and transportation, which is pretty much like vitamin A and D. Okay, pretty much the same. So I'm just going to skip this slide. What does it do? So the big function of vitamin E is its role as an antioxidant. Okay, so we talked about reactive oxygen species a little bit, and I think this diagram is kind of a good example of what happens here. And if we look at a membrane, so every cell in our body has these membranes. Okay, these are all phospholipids. And when you have unsaturated fats here, those unsaturated fats, those double bonds, are susceptible to oxygen. This is what makes fat go bad. Fat going rancid is essentially oxidation of fat. All right? So when we get free radicals produced, which naturally occur in the body, you can increase free radicals by smoking or doing other stupid things. Basically, these guys run around the body and do damage, okay? And they act on those unsaturated fats or whatever it may be and cause damage that can be permanent, screws up the cell function and everything else. Vitamin A antagonizes, so it acts as an antioxidant. It sequesters those little reactive oxygen species, okay? So this free radical, if you have vitamin E around, it'll neutralize it, okay, and prevent it from doing damage. And so this obviously is thought to be a very, very good thing. And these free radicals or reactive oxygen species don't just damage fats. They will affect proteins, they'll affect DNA, they do all sorts of bad stuff in the cell. Okay? They're the troublemakers. And vitamin E, again, vitamin E is very, very important for sequestering that. And as a result, when you buy foods, a lot of foods that have fat in them or have the possibility of going bad, you will see some sort of tocopherol, something in the ingredients list. That is vitamin E. That vitamin E is used to keep that food stable, and to keep it from oxidizing. Okay, this is widely used in a lot of different food products. So, as I mentioned, this reactive oxygen species leads to oxidative stress. There's all sorts of damage, and these can ultimately lead to disease. Okay, there's a big field of people linking that study reactive oxygen species and how they affect cancer development, diabetes, and all of these types of diseases. I won't get into some of the other antioxidant compounds here. There's one. We're going to talk briefly about selenium, a mineral. And this one also has an antioxidant role with this enzyme here, not so important. But these two seem to work kind of as a team. They both kind of are antioxidants, and they synergize to some degree. Okay, so the deficiencies, one of the common ones, the one most people associate with vitamin D deficiency is anemia. Okay, if you don't have enough vitamin D, you get anemia. And you don't see this too often in humans. You do see it in certain conditions. Vitamin E is an issue at birth, especially if you're a baby that's born small or born early. Okay, because we don't have a lot of storage of it. So if you're not starting out at enough level, then you can see some deficiencies. And it also affects, like the other vitamins, affects immune systems, and it affects the brain system as well. The toxicity, not too much. It can cause, it interferes with vitamin K, which we will talk about in a minute. Vitamin K is very important for blood, okay, for blood clotting. And so if you do that, you can cause hemorrhaging or bleeding, which is a very bad thing. But again, most of the issues, if you try and reach the upper limit, much of it is through supplementation. Okay. So the last one is vitamin K. Again, consistent with the theme of fat soluble vitamins, there's two flavors of these. One is really plant-based, and one is really more fish-based, or can actually be made by the gut as well, as I mentioned. So these are the names. I don't even want to pronounce them because I never heard of them. But this is the one that you primarily get vitamin K. Again, fish oil, fatty fish, or meat. You can get vitamin K. And then the phytoquinones are the plant-based ones. You get a lot of leafy green vegetables, spinach, kale, tomatoes, Brussels sprouts, loaded with vitamin K. Okay? And the plant-based one here is the most biologically active, which is unlike some of the others you're going to talk about. So same here, I'm going to skip it. I put it here just for reference, but really the absorption and metabolism of all of the fat-soluble vitamins, again, through the lymphatic system is really the key point here. Okay, so what does it do? The big function is blood. Vitamin K is absolutely essential for your blood clot. If you are deficient in vitamin K, and someone cuts you, chances are you're going to have a hell of a time trying to get that blood to stop bleeding or coming out. And what it does, and I won't get so much into the biology behind this, but thrombin is a protein that really acts as the glue to stiffen up your blood. When there is a cut, it basically goes where the cut is and it clots it up, keeps you from bleeding out. And this is vitamin K plays an important role in actually making that active form of thrombin, prothrombin. Okay, so that's the big one. The other one, it plays a role with some degree in bone health. It has roles as an anti-inflammatory compound. All of these fat-soluble vitamins play a role in the immune system. You'll see this is a kind of a common theme amongst most of the vitamins and minerals we're going to talk about. The immune system is so critical that almost all of these affect it one way or another. And deficiency is pretty rare. You can, going back to the gut bacteria again, if you have a diet that's crappy and you get very low vitamin K, and you have to do something, you're on antibiotics or something like bacteria, it could lead to inefficiency because remember those bacteria can supply some, and enough to keep you going. The other thing, and this isn't so much of an issue anymore because this is common practice, at least I'm sure all of you will probably get vitamin K injections when you're born. We do this just to boost those vitamin K stores when you're born, because you're born with essentially almost no stores. And vitamin K, as far as we know, unlike some of the other ones, there's really no toxicity, unlike the other fat-soluble vitamins. So it's pretty straightforward. Regarding vitamins, this is always a question. Should I take a multivitamin? Are there any benefits? And there's actually a really interesting study came out. They looked at hundreds of thousands of people, and basically came to the conclusion that for most people, taking a multivitamin has no benefit whatsoever. Okay. If you're eating a somewhat normal diet, the benefits you're going to get far outweigh what you're probably paying for. Now, with that said, there are benefits in taking certain nutrients. So if you live in Minnesota in winter, taking a little vitamin D probably won't hurt. Okay. If you're a vegetarian, okay, there's some challenges that come with certain. You can get everything food, obviously, but there are certain minerals or vitamins or nutrients that you might want to supplement. Infants for sure, and certain medical conditions. And the one thing I will mention, I won't get too much into this, is the extreme variability in the quality of vitamins in the market. If you go through, you can buy them anywhere, right? And you look, and people analyze these, there are sometimes maybe the big name ones are pretty consistent because they've been tested, but a lot of them don't have anything close to what they're advertising on. And so that's a concern too. But the take-home point, probably not going to kill you, not going to hurt you, but for many people, it's probably not a great investment of your money. So with that, I believe that's it. So we'll start a little early today. And I will see you guys all on Thursday.